Hello, welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Sorry for the slight delay. We just had a bit of problem with my microphone deciding to be deselected. Anyway, it's working now. Okay, so we're a meetup group and aiming to help people get into Python and even to do some machine learning. I concentrate on the Python stuff myself, and Arun concentrates on the machine learning parts, and he's told me he's really keen to get back into it, so I'm sure we'll see some more sessions from Arun soon. On the first week of the month, we tend to focus on absolute beginners, so people who've never seen Python before, and so just trying to introduce you to the new concepts, just to navigate through that minefield of what's it's such a big field, and to get into it there are so many different paths you can take, so we'll just try to cut out all the extraneous ones and just give you a bit more of a direct route in. So this is a live session. The advantage of a live session is that you can ask questions, and I'll be listening on the YouTube chat. I've already put a little chat message there that my mic wasn't working, and I'm also listening on in Learning to Code channel on Beginners Python, and you've got in Slack. So if you want to join the Slack, the instructions are down below this video. Also below the video in the comments, in the notes section is a link to Google Colab, and that's where we'll be running the session from today, and you can run along besides. So I suggest the first thing you do is click on that link. I'm clicking on the link in the meetup site because it's a bit hard for me to bring up the YouTube site, but it's also there on YouTube just below the video. You might have to expand it. We'll click on that, and that will open us up into Google Colab. Now, Google Colab is a free service provided by Google. It lets you run Python programs on their own virtual private server. They set up one for you, and you can even make changes to this and try different things out. And that's really the advantage of it. It's really great for learning. It's also great for people doing data science, because after each step you can analyze the data yourself and work out what your next step is going to be. When you're in Google Colab, I recommend that you click on this copy to drive, and that way you'll be able to make changes to this workbook, because you won't be able to save any changes that you make to mine, because it's mine and it's in my area. You can view it, but you can't make changes. So if we click on copy to drive, that will create a copy. And you can see now it's called copy of Meetup 221, and it's brought up some release notes. We don't need to worry about that, so I'll close that tab, and I'll close this warning at the top about private outputs. I don't save the outputs in my notebooks, just so that every time you run them, you're getting fresh results. Now there's a connect button up here. You can click on that now. If you don't, it doesn't matter. It'll just click a bit more slowly later on. So Python is a programming language. We have data in that we store, and we use that in our Python scripts. So our learning objectives today is how to use interactive Python, which is this, it's just like normal Python with a few extra things added to aid the interactivity, and interactiveness really speeds up the learning process. So it's a fantastic way of learning, and it's quite enjoyable, and can actually be useful for real setups as well, especially in data science. The data that we'll be storing, we can store integers and real numbers. We'll be storing text data, and we'll be also looking at collections of data that can be stored in things like a list. We'll be putting this data into memory locations, which are called variables. So I'll show you how to create, assign, update them, and also just how to write some little Python scripts. Remember to ask questions as we go along, and see if I can help you. Now this colab notebook, it's a setup a series of cells. You see there's a big rectangle around here if I scroll down. So that first cell's got quite a lot of data in it, or it's just formatted text. So that's a formatted text cell. We can also have code cells. So if I scroll down a bit further, this is what the code cells look like. They're that shaded color, and they've got stuff is formatted slightly differently. I've got a code cell here which has just got some comments in it, which and comments in Python, you start with the hash symbol, and so then Python knows it doesn't have to do anything about it. That those notes there are really for your benefit, so you can read them and Python just ignores them. Okay, so challenge 1 is how to get Python running. And our options are running colab, and so if that's what you're doing, then you've achieved it already. You don't need Python installed on your computer, and colab, they've been keeping it really quite up to date. Recently it's now got Python version 3.12.11, so it's great. If you want to install Python on your computer, you can get version 3.13.7 from this link, and that's the one that I'd recommend if you're going to be using Python. A lot of people use Anaconda as a way of installing Python, and in the early days Anaconda provided quite a lot of additional benefits. It comes with a whole bunch of third-party libraries pre-installed, but these days installing them is really easy at a later stage, and then you only need to install the ones you need rather than a whole bunch that comes with Anaconda. And Anaconda's got some licensing issues, while Python is absolutely free. If you're wanting to write applications, then you'll want an IDE, an integrated development environment. I recommend PyCharm from JetBrains, but a lot of people also use Visual Studio Code, and that's good also. Not quite as comprehensive, but it's more flexible in that it does other languages as well as Python. Okay, so let's get into it. We're going to try running some cells, and the first thing we're going to do is how to find help. So I've got a cell here, and one of the ways using IPython, Interactive Python, or these are called Jupyter Notebooks as well, or IPython or Google Colab, is to put a question mark on a line by itself and then run that cell. So remember, these comments are ignored, so the question mark's the only one that's doing anything here. And if we click on the triangle here, that's the play button to run it, and that question mark has brought up this help over here on the right. So you can tells you how to get help and how to do more help on different things. So you can do help on different functions and other stuff that's in Python. So it's always good to know. But anyway, we won't be going too much more there for now. All right, let's get into variables. So variables are the memory locations where we store data, and you get some data, you store it in this memory location, and then later on you want to get the data out of that memory location so you can use it somewhere. And Python, like many programming languages, just lets you name these variables pretty much anything you like. The rules are you can't use a Python keyword. The names must start with a letter but can include numbers, and you can't include any special characters except for the underscore. So special characters, I mean like quotation marks or exclamation marks or things like that. You can't do that. Use them in variable names, and you'll see why later, because we use them for other things. So for example, if we want to store the number 3 into a variable location called a, then we just type a equals 3, and we run that. And that's ran very quickly in 0 seconds. It stored that, and we just store, like, there isn't a predefined place called A where the number's stored. It's just stored it in a variable location and given it the name A. So to see that value later, we can use the Python print function, so print with these parentheses and the variable name that we want to display. So if I do that, I say print A, it'll display what is the data that's stored in the variable location A. And Python can store any type of data type in any variable. So it's very flexible like that. Sometimes it's too flexible, and that can cause you to get a bit confused sometimes if suddenly you've got some text in there and you're expecting a number, for example. Now also look how Google Colab is doing some syntax coloring for us, and it helps us to understand just what each of the different parts that are typed here will do. So the comment is in green, print is a function, and so it's in this brownie color, and the variable is a variable name is in black, and that's yep. All right, now that's how we do this in Python. Because we're using IPython, there's actually another way to look at what's in the variable A. We can just type A and run that, and we see and whatever's on the last line, if it results in a value, IPython will display it. And so that's displayed 3 for us. IPython will also look at an expression and evaluate it for us. So expressions like an arithmetic expression here, A plus 4. So it takes the value in memory location A, it adds 4 to it, that'll give you a result, and then we'll just display the result because we haven't asked it to do anything else with it. And there's the result, is 7. Now we can store the result of any expression in another variable, and the way we do that is using the equals key. So we say b equals, and then a plus 15 divided by 4, and the reason we've got the parentheses there is just as you would in mathematics. In normal arithmetic you need to specify the order of operations, and it would normally do division before it did addition, but by putting the parentheses in there, it'll do the addition here, whatever's in the parentheses first, and then it'll do the division later. So it's your old BOMDAS rules. Okay, that'll calculate b, and then we want to see what's the result of b, so we just put b by itself on a line, and we get the answer 4.5. All right, now it's really a good idea to try these things yourself. So I've even left a spare, an empty cell here, although now Colab puts in this word start coding or generate with AI. So you can actually use AI to help you do these things. But this is a basic thing, so I think we should be able to do it by ourselves. There's a cell. Type in some Python command to add 123 to 456 and display the result. Now you can pause the video if you want to have a go at that yourself. It is pretty easy. I'm going to just do it now and see, see if I do it the same way that you do. So I want to take the number 123, I want to add it to the number 456, and I want to see the result. And so I'm going to press Shift Enter, because if I hover over here, I know that the play button was Control Enter will run the cell, and Shift Enter actually does very similar. It runs the cell and moves me down to the next cell. So let's do that. And so that's displayed the result, 579, and that's exactly what we wanted. Now all the way through this video at any time, if you want to try something different, you can just add in an extra code cell, click it in, and type away. You go, what happens if we add them the different way around? And it gets the same answer. So it just helps us, shows the commutative rule in addition, that we can swap the order without changing the result. Okay, now I've actually got a solution here pre-baked, and I'm doing it a slightly different way. So the solution we did above was using the IPython technique of just making an expression and getting the result coming out, but we can use print commands to also display the result, and this way we can display some text labeling what the result is and then doing the result. So if I run this, I get this text come out. Solution 2 works in IPython or Python, and we have to, if we're in Python, we have to do this because Python doesn't automatically display the results of an expression. And then what the result is, 579, which you can see is the same as before. All right, now we're going to, here's a few lines of Python code, and what I want to do is to show you what the list of keywords are in Python, because remember, you can't use these keywords in your as a variable name. So it's useful to know what those keywords are that you can't use. If you try to use them, you'll find out pretty quickly that you can't use it as a variable name. But there is a way to get the list, and it's the list is in a library called keyword. It's a standard library, but to use it we need to import it first so that Python knows something about it. Also, we're going to import sys because I want to find out what version of Python is running here. So we import those two libraries, and once they're imported, then we can look at the keyword list from the keyword library, and we can look at the sys.version from the sys library. So, and I'm just using some print commands to print them out. Two forms of the print command, the print function actually. When the first one, I've just got two things to display, so I'm just putting a comma between them, and they'll just print on the same line. The second one, I'm using what's called an F string, and we'll get into that later. And I can I can add things into the middle of a sentence more easily using these F strings. So let's run that. Python keywords are, and here they all are, false, none, true, and as. And I think you'll find that if we go along, we'll find that import is one of the keywords. And you can see import here is in a purple color. So when you type a keyword into Colab, it does some syntax coloring into a purple color. So that's good, a good clue that you're using a keyword as a variable name if that should happen. All right, there are 35 keywords in Python 3.12.11. So that's the version of Python that's running on this Google Colab, and there's 35 keywords. So it's not a lot, and we're going to look at 14 of them in this session. So, you know, if you're going from a standing start, you're almost got halfway through all the keywords in Python. So that should be impressive. The first one we're going to look at is none. What is none? And none here is a value to give to a variable if you don't want it to have a value. So I'll say n equals none, and then I'll put n here, and let's see what it displays. It displays nothing. So none is useful if you don't want a variable to have a value, and you can also you can check if something is none. All right, let's look for another keyword. How about pass? Pass is a programming command, and it does nothing. So once again, very easy. There are times when you need a line of code in your program that does nothing. for example, when code is expecting an indented code block, but you don't actually want to put in any code in that block, then you can use the pass. That's probably the main time you would ever use it. But they needed to put have a keyword for that role, and that's what it is. Okay, so we've done three keywords now: import, none, and pass. Yep. Okay, so none is actually colored blue, probably because it's a value rather than a command in Python, even though they're both keywords. All right, now variable names. We've been using some very simple variable names like a, b, and n, but it's useful to use longer variable names because when you are reading them later, it reminds you what the variable is supposed to be storing, and it also means you're less likely to clash with the keywords if you're using a variable name that's got more than one word in it. The convention is to use all lowercase for your variable names and to separate words in the variable by underscores. But that's not a rule. You don't have to do it. You'll find people coming from Java will often use camel case, which means they start with a lowercase letter and then every word in the variable name gets a capital for the first letter and then lowercase for every other letter, and but they don't have any underscores in them. Java can actually name variables like this with the underscores as well, and so it's really just a choice of in your language which way you do it. You can do it in Java or Python, and the writer of Python decided that this is going to look good. If you look at some very old libraries, you occasionally come across Python variable names that have used the Java convention. Okay, so we've done a little bit on variables. Now let's look at data types. So this is the different sorts of data that can be stored in a variable. So remember, we've got the variable a, and we want to see what the data type of that value is. We can use the type function. So we say type, and then in parentheses we put the variable name, and it'll tell us it's an int. Similarly, if we typed in a literal number like 456, and what's the type of that? That is also an int. So ints are integers or whole numbers, so they don't have any fractional part. And then there's another type called float, and floats are the floating point numbers, so they have a fractional part, which is normally represented by a decimal point. And so if you remember what b was, so we just add a code. What was b? B is being very slow on this one, 4.5. So you can see it's got a fractional part to that number. It's not a whole number. Okay, so the way these floating point numbers are stored, they have a mantissa and an exponent, making it possible to store very large or very small numbers in a small amount of memory. And the position of the decimal point floats through the number depending on the value of the exponent, and that's why they're called floats. So if I look at this number here, which I've typed in like this, it just it stores it internally as 1.2345678 all the way up to, and then the exponent by 10 to the power 19. Then I've got this other number, which is a very small number, so that was a very big number. Now I've got a very small number. And how is that stored? It looks very similar. It's got the mantissa is the same, 1.2345678 etc. And then the exponent is by 10 to the minus 14. So it's this exponent is the only thing that's different between these two numbers, and it just specifies where this floating point exists in the number. Okay, so there are numbers and text. We can also store text in variables, and they're called strings of characters. In Python 3, these characters are Unicode characters. In Python 2, they're only bytes. So a byte is 8 bits, and and each bit is a 1 or a 0. So you've only got 256 different values for a byte, and part of those, that 256 has been used for your letters of the alphabet, and then a few others are for things like they've used a few of those characters just for like umlauts or acutes or subscript 2 or a couple of funny shapes. But that's just ASCII is the bytes, but Unicode gives us thousands and thousands of different characters. You can have characters from all sorts of different languages, like Chinese and Japanese and Korean, and they can be multiple bytes long, and there's no real limitation. And so that's because of the advent of Unicode characters. That was one of the driving forces for going from Python 2 to Python 3. So to write a string, you just put in your text that you want, and then you put quotes around it. Now the quotes can be either single quotes or double quotes. They're really treated the same, and you can choose whichever one you want. Often you would, if you had a string that you wanted double quotes inside the string, then you can't use double quotes as the end delimiters of the string. So in that case, you would use single quotes. Similarly, if you had single quotes inside your string, then you would use double quotes at each end. Now there's also a thing called a triple single quote. So you just get a single quote and you type it 3 times. When you do that, then you can actually have inside your string, you can have single quotes, you can have double quotes, and you can also have line feeds. So this string has actually got a line dropping down. At S4, I've got here as another string like that, only this one is surrounded by triple double quotes. So let's have a look at the differences between, especially the difference between S3 and S4. The single quote, triple single and triple double isn't the cause of the difference, but see if you can see why there's a difference between S3 and S4. So they've printed out here, we've got S1, S2, S3, and S4. And the reason that S3 has got this big amount of space here is that even though they it looks like it's just a line feed and we've just continued on, we have actually included all these spaces in our string, and so they get saved there and will get displayed when printing them out. And when we use our type function to see what data type it is, it returns str, which is Python for string. Now sometimes you want to put special characters in our strings, and so we use the backslash to be able to do that. So we can, if we wanted a new line in the string, we can use \n, or a carriage return we can use \r. And so in Windows, in text files, the end of every line is traditionally a carriage return followed by a line feed or a new line. In Mac, well, in Linux and Unixes, the end of each line is just a new line character. In the early Mac days, the end of each line was just a carriage return. So 3 different operating systems all had 3 different ways of ending the line in a text file. But that's why you might want to put these line feeds and carriage returns into your text file, and so that's the way you can do it if you explicitly want to make sure you get it exactly right. Similarly, if you wanted to put a single quote into a string that was delimited by single quotes, then you can say backslash single quote, and that'll say give me a single quote but don't end the string on it. And similarly, if you wanted a double quote inside a string that was denoted by double quotes, you can use backslash double quote. Of course, this all means how do you put in a backslash, because backslash can have all these extra meanings, and the way you do it is double backslash. So let's, I've got all these special character strings, SC1, SC2, SC3, and I'm going to print them in using this print statement, the print function with commas between them. So a comma would generally put a space between each one. So let's have a look what it would look like if I do the number 1, then a new line, the number 2, then a carriage return, number 3, and then a single quote. All right, so we can see the number 1, and then we've done a new line, so it's dropped down to the next line. Then we've done the number 2, and we've done a carriage return. So a carriage return, if you remember a typewriter, carriage return is the carriage which you were typing against, moving from one side to the other. And so a carriage return just puts the cursor back to the start of the line where the 2 was, and then we want to print a space and then the 3, and so the space actually wipes over the 2 in what it looks like. So you've got to remember how these typewriters used to work, and to understand what is going on. New line means that the roller of the, I think it's called a platen on the typewriter, is rolling up, and carriage return means it's the whole carriage is moving, so that where it types is now at the beginning of that line. The rest looks similar. We've got a single quote, then a 4, a double quote, then a 5, and then a backslash. So there are no surprises there. Now these strings can have prefixes before the first quote, and if you've come from another programming language, you might find this is a bit of a surprise. I was surprised when I first saw it. And if you want to make sure something is a Unicode string, you put a U before the quote. And remember, these quotes can be double quotes or single quotes or triple single, whatever. Doesn't matter, but you just put the letter outside the quotes and you say this is a Unicode string. This is the default in Python 3, but if you want to use a Unicode string in one of the later versions of Python 2, then that's how you would do it. Similarly, if you wanted a byte string, which is the Python 2 way of doing it, you would put a B out the front. And the advantage of this was that you could then write some code that would work in both Python 2 and Python 3, and that helped through that transition period, which was very painful for a lot of people. So because you had to, otherwise you'd have to wait till every one of your programs in your Python programs could work in Python 3 before you could stop using Python 2. But if they were all, if they were changing so that they could run in 2 and 3, then people who were only running one program could switch to Python 3 earlier, and it was only the people who are running a lot of programs and some unusual ones that had to stick with Python 2 for the long haul. Then we've got raw strings. So in a raw string, a backslash is just a backslash, and this is useful if you're wanting to do things like this, because otherwise it can get quite if you're doing a lot of backslashes and you're having to do 2 backslashes for every single backslash, and especially if you're doing regular expressions where it also requires you to do 2 backslashes if you want a single backslash, then you end up with 4 backslashes or 8 backslashes, and it's very, very confusing. So they created this raw string format where the backslash is just a backslash, and so it makes it very easy. And you can see there's no color coding happening there. Actually, there's no color coding happening here either, so nothing special there. And then the F string. F strings, they're a recent introduction to Python, but they've I think it was about Python 3.6, but they've been very, very popular once they came, and all other ways of formatting strings have just gone by the wayside. So if you're wanting to display data, F strings are the way to go. So let's have a look at what these different strings look like when I print them. So you can see the Unicode string just prints out normally. The byte string, when I try it using the print statement, it actually puts the B out in front and goes, all right, you're printing a byte string. I'm going to display it slightly differently so it's clear that it's a byte string. The raw string, all the backslashes are just backslashes, so that's good. Yep. And the format string, I've put variables inside these curly braces, and it's actually evaluated what's inside the curly braces and displayed it. So the A got evaluated to a 3, the B got evaluated to a 4.5, and the A plus B got evaluated to 7.5. So you can see how powerful it is. All right, let's move on to operators. These are the symbols that we use when we're creating expressions. So we've seen a couple like plus and divide. And I'm going to quickly use f strings to display a few different operators that are available in Python. First we'll start with the integer operators. So the plus symbol gives us addition. So we can 27 plus 5 equals 32. The dash symbol is subtraction or minus. The asterisk is multiplication. You can see, so 27 times 5 is 135. And now for integer division, if we want to divide one integer by another, we use double forward slash. And the reason for that is we're saying we want to divide these two integers and we want the result to be an integer. So it's called floor division. So it does the division and then it goes down until it comes to a number that is an integer. So 27 divided by 5 is 5.4, and so it goes, well, 5 is the integer, and then what's left over will be the remainder. And we've actually got an operator that will tell us what the remainder is. So percent is the modulo or remainder operator. So 27 modulo 5 is 5 remainder 2, and so that'll return 2. And the last one, double asterisk, is power. So 27 to the 5th power. So it's 27 times 27 times 27 times 27 times 27 will give us this large number. All right, how are you all going? You understanding this? Any questions? And you notice in all these results there's no decimal points. Okay, so let's do similar thing with floating point operators, which in a lot of cases they're just exactly the same. So what we'll do, we'll start off with a, rather than it being an integer, we'll make it a floating point number. So 27.0, so it's the same number, but it's a floating point number. So if we run the same set of operators, we'll see that 27.0 plus 5 returns, and it actually returns a floating point number, 32.0. So once you start for a float, it'll convert to a float, and you have to explicitly say if you want to convert it back to an integer. Now because of that, we've got a bit more flexibility in division. We can actually do floating point division as well as whole number division or integer division. So floating point division will give us 5.4. Whole number division will return 5, but still as a float, and the modulo still works, but the remainder is also a float. And similarly, power is a float. So we could also do, I'm just going to 27 divided by 5. So we're using floating point division, but on integers, and that does come out as a float, 5.4. All right, so I've got a challenge for you. See how you go with this one. Store the variable C, the number 123,456,789, and then display double the value of that. Alright, so pause the video if you want to have a go. I'm about to do it now. C equals 123,456,789, and we want to display twice that, and there's the result. Okay, so that was not too hard. So you can use Colab just like a calculator if you want. Quite useful. Alright, solution 3. Here's a built-in solution and that I created earlier, and I can run that, and I like to just introduce some new concepts with these solutions. So one of the concepts I've introduced by looking at this number 123,456,789, it's difficult to get a feel for how big a number that is because we're used to grouping the thousands. Now we'd like to group the thousands with commas because that's what we do when we're writing numbers that are big numbers, but a comma in Python means something else. It means it's the start of a new number. So Python does give us a way of typing in these numbers in a way that will make it clear that we're grouping by thousands, and that's using underscores. So if we put underscores in our value for C, it was as if the underscores weren't there, but it really helps it make it easy for us to see exactly how big that number is. That's good. All right, so Keith says all is good. Very good. Okay, so double C is the same answer we got before. We could have put it in an F string, 2 times C equals, and evaluated it that way. We can actually also put formatting in these F strings. So after our expression, the first one is I've put an equals sign in there. So when you put an equals sign in, you get two things happening. It displays both the expression and the result of the expression. So that can save a bit of typing, and that's really useful when you're doing logging. Otherwise you just have to type it twice. You know, say this variable equals and then what the variable actually equals. But by just putting it inside the brackets with the equal sign, you get what the expression is and the result of the expression. But you could also do formatting. Anything after a colon is formatting, and one of the formats you can use is the underscore format. So if we format that number with the underscore format, it does exactly as we did ourselves manually, which was separating each group, thousands group, by the underscore. Similarly, we could put a comma there and it would separate by commas, or we could say put in a comma and give us a decimal point and 3 places after the decimal point, and I'm specifying that I'm using a floating point number here, and I want the total width of the number to be 17, so it's 17. It's padded some spaces out the front, so that way it makes it easier for me to align the decimal points later. I've got 3 decimal places after the decimal point, and I've got commas separating the numbers. So that's quite powerful. And there was something else. Oh yes, so the other one thing that I'm showing in this F string is sometimes you actually do want to display a curly brace, and so to do that you put a double curly brace in the F string and it will come straight out as a curly brace. Alright, find the remainder after integer dividing an odd number by 2 and then try an even number. Alright, so these are great little exercises to get you a feel for how numbers are working in Python. So I'll just choose a odd number, say 3, and we'll find the remainder after dividing that by 2, and that's 1. And I'll make another code cell. I'll grab an even number, 8, 2, and the result is 0. All right, so that's interesting. How could we use that? Well, I've got a solution here that starts to loop through five numbers starting from 0. So that's using this range function to give me that, and I've got a for loop. I'm jumping straight into for loops. That's not really the focus of this session, so but it's useful for you to see what they look like. A for loop, you have for, you put a variable name here, in, the word in, which is a keyword, and then the range. So you could have a list of numbers here that you want it to have a different value each time, or range will give you that number of numbers starting from 0, so 0, 1, 2, 3, 4, 5. And then a colon, and the colon means I'm about to start a code block. And so the next line, I'm in a code block, and to make it clear I'm in a code block in Python, you specify this by indentation, which is different to pretty much every other language. So we put in 4 spaces is the traditional number of spaces in Python for indentation, but it can be 2, that will work as well. And then we put in our expression, and because it's indented, this code block is considered to be in the loop. So everything in the code block will be repeated the number of times it's going through the loop, which is 5 times. So I is going to go from 0 to 4. Every value of I, we're going to find the remainder after dividing by 2, and we're looking at the remainder, and it's 0, 1, 0, 1, 0, 1. So now we're seeing something that oscillates between 0 and 1. So this could be a good way, say you wanted to do, shading on every second line, or every second line in a display wanted to have a different color, and that's how you could use this sort of feature of modulo 2 to achieve that. All right, now let's look at some other operators. You probably won't use these a lot. They're called the bitwise operators. So they work on binary numbers. And the ones we're going to look at, we've got this vertical line that's called the pipe symbol. We've got the ampersand, the circumflex, double less than, double greater than. So let's run it and see what the results are. So we've got A is 10, B is 3, and we say 10, and this symbol is actually the OR symbol, bitwise OR. 10 or 3 returns 11. Okay, now if we want to understand why does 10 or 3 return 11, it's useful to look at these numbers in their binary form. And our great F strings give us a way of formatting our numbers into binary. So we have A, we want it to be 4 characters wide and in binary, and so it'll convert the number 10, the decimal number 10, into binary, which is 1010. And similarly, the number 3, convert it to binary, which will be 11. But we also want it to be 4 characters wide, and we want it to be padded with zeros and right aligned. So that's what this 0 greater than means. The 0 means padded with zeros, the greater than means right aligned, and 4 characters wide and in binary. So that gives us 0, 1, 1. And now we can look at each of the characters in our binary numbers one by one. So when we've got an OR, that means that if either of the numbers is a 1, then the result is a 1. So for the first digit, we've got 1 or 0 equals 1. 0 or 0 equals 0. 1 or 1 equals 1, and 0 or 1 equals 1. So the result is 1011 in binary, and if you convert that back to decimal, you'll get 11. Similarly, AND requires both bits to be 1 to produce a 1, otherwise it'll produce a 0. And so 10 ampersand 3 will return 2. 10 exclusive OR 3, that means if either one is a 1, then the result will be a 1, but if both are a 1 or both are a 0, then it'll be a 0. And so that's called XOR, exclusive OR. And then we've got shift left and shift right. So it takes the bits and shifts them left. So 0, 0, 1, 1, shifted left 2 places, returns 1, 1, 0, 0. And similarly 1, 1, 0, 1, shifting right 2 places will give us 0, 0, 1, 1. Where would you use this? Possibly in electronics, if serial communications, that sort of thing, can use this if you, but it's there in Python if you do. Alright, so that's operators on numbers, operators on binary numbers. Now we're going to look at some operators on strings. And the string operators we can use are the plus and the asterisk. And the asterisk is just like multiplication. So if I run this, we get well, 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 because we've got the well times 3, and then we want to add it to another string, which is 3 holes in the ground. So we get well, 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 3 holes in the ground. Now when you're creating strings, if you've got adjacent strings, you don't even need the plus. It always confuses me when I see code like this, but so I've got 4 strings here, and I've just got spaces between them, but Python will just join them all up as if they had pluses between them to make one long string. Alright, so let's have a look at some of the interesting side effects of the different data types in Python. One of them is integers can have more significant digits than floats. So even though you might think integers for small numbers and floats can be for big numbers, you can actually use, and especially in, it wasn't the case in Python 1, but in Python 2 and 3, integers can be a lot bigger, and there's no limit now on how big your integer can be. And it will save all the significant digits. So if I've got a big number like this, 25, and how many gazillion that is, if I divide it by 7, I can see I get a lot of numbers. Now if I did that as a float, it would if I did that as a float, it would lose some of these digits, and we'll see that. Oh, here it is. Here's the float. That returns that, and double slash, it returns this. So you can see I can see more values in my decimal places, even though I haven't got a decimal point. I can see all what the digits are. And so that's useful if you're doing something like calculating pi to 1,000,000 places. You can do it all in these integers with a million digits, and it would and you'd be able to display it. All right. Now another interesting side effect is that floats can't store decimal numbers exactly because it stores them in a binary format, but you normally floating point numbers are coming from base 10 fractions. So if I had 1.1 plus 2.2, you'd think the answer should be 3.3, but in fact the answer is 3.30000. So very, very close to 3.3, but because those numbers 1.1 and 2.2 weren't stored as exactly binary equivalents, then the result turned out to be not exact. So that's something to be aware of. If it's important to you, use the decimal package rather than floating point numbers. And so if you're doing accounting, you probably use decimal. If you're doing scientific applications, then you probably floats are going to be faster and better for you. Okay, find the integer quotient and remainder when dividing 66666 by 235. Okay, so the quotient 666 divided by 235 with the floor division, and I can do two expressions on the same line here. I just separate them by commas. 66666 and remainder 235, and the result is 2,836, remainder 206. Okay, calculate 2 to the power 10. 2, 10, 1,024. Find the decimal quotient of 666 divided by 235. Uh, 2836.876, etc. Store in a variable the name of your favorite programming language as a string. Construct a new string. So let's call it P equals Python. Construct a new string that starts with programming in, finishes with is fun, and includes the value of the variable in the middle. So I might just use the string operator, the plus, and AI has done it for me. Is fun, and I need to close that quotation marks and run that, and I get programming in Python is fun. Alright, so they were a few little exercises there. Let's have a look at the solutions. And they're all exactly as I did. And this I used F strings here rather than the plus operator. Okay, now another data type is booleans, and they can be true or false. And in fact, two of the keywords are true and false. So let's have a look at what the type of those are: bool and bool. Now, often when we use a conditional operator, we will get a result which is a true or false. So let's have a look at some of these operators. Remember when we used a single equals, that was for assigning a value to a variable. Now there's the double equals, and that's saying is the left side equal to the right side. So the left side is 3, the right side is 5 minus 2, which is 3, so are they equal? True. That's an equality tester. We can test if one is greater than another. True. Negative numbers, false, so minus 10 is actually a higher number than minus 20. So if we say is it less than, we'll get false. C1 equals Python. What do you think we'll get for that? And the answer is true, because we stored Python in C1 before. Challenge 6. Predict the outcome of the following Boolean expressions. So C1, well, it's in this here, C1 equals Python. What do you think we're going to get the result there? So think about it and then run it, and the result is false. And the reason for that is that C1 is Python with a lowercase p, and C1 is Python with an uppercase p, and we're comparing it to Python with a lowercase p, so the result is false because it's a case-sensitive comparison. The next one, C1 does not equal, that operator means does not equal, so it's an exclamation mark followed by an equal sign, Python. So if equals returns false, then does not equal should return true, which it does. 253 greater than or equal to 1518 divided by 6, and that should return true, and that's because it did the division first before it did the comparison. Once again, we can try less than or equal to, so that's a greater than or equal to symbol. These operators were created before we were using Unicode, so there wasn't a greater than or equal symbol in ASCII, so we created our own by using the greater than sign and the equal sign next to each other. And similarly, less than or equal also returns true, and that's because that divided by 6 equals 253. So that's why greater than or equals is true and less than or equals is true. Now we're going to look at some values in the math library. So for example, we're going to look at, it's got some irrational numbers like the irrational number e, the irrational number pi. It doesn't really store the irrational numbers, it's just storing an approximation to the irrational number because it's only got a limited amount of memory. And that's usually good enough for the accuracy, is 17 decimal places. So e is less than pi, that's true. You can also have comparisons, more than one comparison happening. So you can say e is less than pi times 2 is less than tau, which is 2.7 is less than 6.2 is less than 6.2. Now, because tau is actually the same as 2 pi, that's going to return false, because that should have been less than or equal if we wanted to return true. Let's look at some characters. A is less than C, that returns true. It just compares the Unicode values. A is less than capital C, returns false. And that's because the I was just going to get a drink of water. So uppercase characters in ASCII appear before lowercase, and in Unicode they did the same. They kept all the ASCII characters the same. So A is lowercase a is actually a higher value than uppercase C. And you can see similarly the full word upper is less than lower, that returns true, because the uppercase characters come before the lowercase ones. We can do longer words, and it just works out alphabetical order for them, with that caveat about upper and lowercase. There's also another operator in, so we can say is AT in catch, and the result is true. Is AC in catch? Well, A is in there and C is in there, but they're not. AC is not in there with the letters together, so that returns false. And similarly, TA is not, because the order is important as well. And you notice that in is a keyword that's in blue, so we've done another keyword for you. And remember, true and false were two keywords as well. Now you can say true or false, that returns true. True and false returns false. So that's really definitions of or and, also keywords. But if you get true or false and false, and this is one that I never remember, that's going to equal true, because and has precedence over or. So the second and is evaluated before the first or. And if you wanted to specify the order these are evaluated, then you need to put parentheses around them. Similarly, it's just another example. False and false or true returns true. The is operator is if you want to compare two variables are the same value, and when I say value, is means that they're stored in the same location in memory, so they can have the same value, and is would return false. For beginners, you would normally only use is if you wanted to compare to none, because there is only one none in the whole in your whole program. So you can compare a is, if a is none, then do something. So that's how you would do that comparison. One more data type, is the list. So a list can be a collection of different other data types. We're going to join them together with, we'll group them with these square brackets and separate them by commas, and we get a list of all these different values. And then we can do things like referring to a particular, their 0 index, so list 0 is going to be the first one, so X, list 1 is going to be the second one, 5, list 6 is going to be 0. But some of the fun things you can do with lists, with indexes, is that you can start counting back from the end. So you can say -1 is the last one, so that's 0, -2 is the second last one, and that gives us 1. We can find the length of the list. We can slice the list using this column. And we're running out of time, so I won't spend too much time on this. But this is how I like to remember how the indexing works when you're doing slicing. So it's really marking the gaps between the values, and so if I want to slice from 3 to 5, I'll get these two values there. And there's some more examples. You can even put in 2 colons, and then you can step up in 2s, 5, 3, 1. And you can put negative numbers if you want to slice backwards. Lots of fun. All right, we can assign a value to, say, the index 2, and now we've changed from 4.0 to FOUR, and we can change the 0 to blast off, and we can delete an item in there, so you can see the index 3 value has gone. That's not the string we have. I've chose a poor example there, but it's that's the one I've deleted because it's index 0, 1, 2, 3. Just like lists, strings can also use this slicing notation. And I mentioned before how, if you wanted to do an accounting application, how you do it, and you use the decimal library. So we import that and we create our decimals. The decimals have to be created from strings, because if you create them from a floating point number, it's too late. They've already had the inaccuracy added to them by storing them as a binary when they're a base 10 number. This notation is pretty verbose, but there's a couple of things you can do. Rather than just say import decimal, you can say from decimal import capital D decimal, being the class, and then you can refer to it that way. And sometimes people even will say from decimal import decimal as D, and you can do this. So let's run all these. Decimal 3.3, decimal 3.3, decimal 3.3, so that they're all equivalent. And this importing a library as something, or you can import a library as an alias, or you can import a function in a library as an alias. And this is often used in for pandas and numpy. So if you're doing data science, you'll see this quite often. Import pandas as PD, import numpy as NP. Right, so these are the keywords that we covered today: false, none, true, and as, till, whatever. And if we count them all up, there were 14 of them. So I hope you enjoyed that. I hope you learned something. And remember, just keep doing the exercises and typing in bits of code, seeing what happens when you do things, and that's the way you're going to learn. All right, I'll be back in a couple of weeks' time. Arun might be back next week, or in 3 weeks, and so you can check out the meetup group to see what's coming up, and if you want to look at any of our past sessions, that I've done, you can see on GitHub, or you can subscribe and see all my my videos. So in BPAML sessions, which is Beginners Python and Machine Learning sessions. In the online folder, you'll see all the sessions I've done and a couple that others have done as well. And if you look at them, you'll see I often give links to the Colab notebook, the YouTube video, and even the meetup event. You can't think of any reason why you'd want to go back to meetup, but Colab and YouTube are two useful links to go through these. Okay, until next time, we'll see you later.